All right, Algebra 2, welcome back. Let's go ahead and do some more rational equation examples just to expose you to different types. So we talked about cross multiplication in the first video, and I kind of hinted at, you can use it when you have a fraction equals a fraction. But now if we look at this right here, we can't really rely on cross multiplication. And the reason why is because I don't want you going and doing this. I don't want you to cross multiply this. No, bad. Don't do that, okay? Just gonna undo that. All right, do not cross multiply here. You can only cross multiply across an equal sign if I have fraction equals a fraction. Not when I have multiple fractions is equal to a fraction. Right here I have multiple fractions equals one fraction. That's technically 2/1. Don't do it, okay? If I see it, I'm gonna be hurt. I'm gonna be deeply offended. So what do we do here instead? Well, what we could do, kind of something we've already been doing, is we could get a common denominator here and then get one fraction and then cross multiply from there. But you're gonna find that something that might be a little quicker is just to multiply both sides by least common denominator. Okay, this is what you should do when you have multiple fractions, either just on one side or on both sides, even if you have it on both sides, okay? And that's gonna be the least common denominator of all fractions, okay? Not just on one side or the other, it's on all sides. Okay, so let's find the least common denominator here. Okay, well, if you take a look, it's either x, 3, or 1. We don't really care about the 1, so it's just between x and 3. X and 3 have nothing in common, so our least common denominator is just gonna be 3x. Okay, so let's go ahead and just multiply both sides by 3x. So multiply this side by 3x, multiply this side by 3x. All right, what does that mean? Careful when you have a side with multiple fractions. You're going to need to distribute because there's an addition and we're multiplying, okay? So I do 3x times 2/x plus, I'll go ahead and put that in parentheses, plus 3x times 4/3. Let me erase this. Is equal to 2 times 3x, okay? So before we multiply, let's see if we can simplify a little bit. These x's can definitely divide each other out. So here I'm just left with 3 times 2. Plus, I can simplify these 3's out. Here I'm just left with x times 4. And then on the right-hand side, this is just going to be 6x. Okay, cleaning it up a little bit more, I get 6 plus 4x equals 6x. Okay, this took us a little bit less time than it would have if I got the common denominator on the left side and then cross multiplied it. It took a little bit less time. So let's do this, okay? Multiply both sides by the least common denominator to solve rational equations when you have multiple fractions on either side or both, okay? We can use cross multiplication if it's just one fraction on each side of the equal sign, but if there's multiple that are combined with addition, now if it's with multiplication, that's a different story. Because when you multiply two fractions, you can just clean it up very easily into one fraction. But when you have multiple fractions combined with either addition or subtraction, then let's go ahead and do this, okay? So let's go ahead and get x by itself, subtract 4x on each side. I get 6 is equal to 2x. Just divide 2 over, we get x is equal to 3. Okay. What can x not be? The only variable we have in the denominator is this x over here. So the only issue we need to be careful of is x shouldn't be 0, right? Because there's no way I can get division by 0 here. It's already 3, I can't change the 3. And then same thing over here. It's already a 1. I can't just manipulate it to be something else. I mean, I could, but I couldn't manipulate it to be 0. This x is the only issue I might run into. So I can't have x be 0. And does that check out? Yes, our answer is 3. Okay. How does that sound? Hopefully that sounds okay. Let's do 2 more examples to get you on your merry little way. Okay, here's another example where we have multiple fractions combined with addition or subtraction on each side of the equal sign. So let's go ahead and multiply by the least common denominator. Let's do it first this time though. What can x not be? X can't be 0. That's one of them from this fraction. And then from these two, they have the same denominator. X can't be 3. That's kind of ugly. Let me rewrite that. X can't be 0 or 3. Okay, so now, as we have been doing so far, we're going to use that to compare our final solutions. Okay, so what's our least common denominator here? Okay, they don't have anything in common because I just have x minus 3 and x. So it's x times x minus 3 is our least common denominator. Let's multiply both sides by that. So I get x times x minus 3 times x minus 3, under 2. I was going to say 2 over x minus 3 is what I meant to say, plus x times x minus 3 times 1 over x is equal to x times x minus 3 times x minus 1 over x minus 3. Okay, so remember we multiply both sides by the least common denominator. I went ahead and skipped a step and I distributed the x times x minus 3 to both parts on the left-hand side, okay? We multiply the entire left-hand side, so that means we got to multiply each of the pieces, each of the parts that are being added. Okay, in my first fraction, I can simplify out this x minus 3's. So I have 2x remaining. And the second piece, I can simplify these x's out. So I'm remaining with x minus 3, sorry, equals to, on the right-hand side, I can simplify the x minus 3's out. I'm left with x times x minus 1. Okay, now let's keep going. 2x plus x, that's 3x minus 3 is equal to x squared minus x. Let's get everything on the same side. Let's go ahead and subtract 3x, add 3. Subtract 3x, add 3. We can just kind of flip. I get x squared minus 4x minus 3 is equal to 0. Okay, can we factor this or plug it into the quadratic formula, whatever your desired method is? We can factor. That's going to be x minus 3, x minus 1. Ooh, did I mess up somewhere? Yes. I was like, wait a minute. This should be plus 3. There we go. That fits now. I was worried that negative times negative was not negative, but this should have been positive because we added the 3. We're good. We're okay. We're fine. Is equal to 0. Okay, so then that gives us solutions of x is equal to 1 and 3. Okay, but wait, right? The whole point of doing this up here is to make sure we check. Notice something. It doesn't agree. Okay, the 1 is okay because the 1 is not restricted from the top, but the 3, if I plug 3 in, I do get equals. Like they do give me the same thing, but I get that division by 0, and I don't want that. So I actually do not want to keep 3. My only answer is x is equal to 1. Okay, and so what we say that x equals 3 is an extraneous. That's what this word is, okay? Extraneous. Did I spell that right? Yes, extraneous. Extraneous. Okay, x equals 3 is an extraneous. Extraneous is an adjective, not a noun. Is an extraneous. Okay, now I can't even spell it. Wow. Okay. Sorry about that. Let me do this right. Extraneous. Okay, good. Solution. Sorry. Okay, it's not just an extraneous, it's an extraneous solution. Singular. I can't English right now. Sorry about that. There we go. Okay. Whew. X equals 3 is an extraneous solution. Okay, what does that mean? That means x equals 3, while it makes this true, it's not in the domain, right? Our domain for these solutions is that x should not be 0 and x should not be 3. X can be whatever whatever it wants, the solution is 1. And I'm allowed to plug in whatever I want. It might not get equals, but the one that'll make it equal is 1 and technically 3. But because 3 cannot go in because it'll cause division by 0, I don't want to include 3. Okay, so that's why it's called extraneous solution. An extraneous solution is one that makes this true, but it's restricted by the domain. Okay, hopefully that makes sense to you guys. So just kind of something to take away from here is that you might get multiple solutions, you might get one solution. You always need to check against your the restrictions you find at the beginning. That's why you always got to find them first. Okay, let's do one more to kind of send you away and to show you kind of another example of an extraneous solution. Okay, so we got 5x over x minus 2 equals 7 plus 10 over x minus 2. X cannot be what? 2. Okay, I'm not allowed to plug in 2 because then I'll get division by 0. So, and then there's nothing from the 7, so we don't have to worry about it. So then what's our least common denominator, seeing as we have multiple fractions on each side combined with addition or subtraction? Well, the only denominator we have is x minus 2 and 1. So really our least common denominator is just x minus 2. Okay, so let's multiply both sides by x minus 2. So we get x minus 2 times 5x over x minus 2 is equal to 7 times x minus 2. Remember, we got to multiply everything, plus 10 over x minus 2 times x minus 2. Okay, so on the left, x minus 2's go away. They simplify each other out. We get 5x is equal to 7x minus 14 plus, these x minus 2 simplify out, 10. I'm gonna do a few steps in one here. I can subtract this 7x over, and then I can combine these two. So I get negative 2x is equal to negative 14 plus 10, that's a negative 4. So then x is equal to positive 2. That would be our solution, but what do we have up here? X can't be 2. So I actually can't include 2. But that was my only answer, right? So x is equals 2 is extraneous. Okay, I want you to write that on your paper every time you come across an extraneous solution, just so you can keep track of what the extraneous solutions are, right? We found an answer, but we can't use it because we get division by 0. Okay, so well, then what's the answer here? There is no real solution. Cool. So rational equations, you can have no answer, you can have one answer, you can have two answers. We won't deal with anything more than that for rational equation. But there is your there's your walkthrough for rational equations. Okay, make sure you're asking questions when you can, and I will see you guys in the next one. Okay, have a great rest of your day.